Okay, could you pull up Pirate and share your screen with me?
Yep.
Oh, you have to like, and then not that one. Can you go back? It's coding in Pirate. Do you see like, it's the second option, coding in Pirate?
Oh, sorry.
Yeah,
This
that
one.
one. Open editor. Perfect. Okay. Could you command plus a few times just to make the text bigger?
Um, Comment? What
Yeah, command
command
plus.
line? Command plus. Yeah, sure.
Yeah, just to zoom in. Perfect. Okay. Okay, so today we're gonna cover a new concept. So based on the yeah, based on the revision you gave me last time, just now, we covered numbers, arithmetic, and variables. So we covered a
Mm-hmm.
bit of algebra. Another important idea of algebra is functions, and so we're going to cover that now. Okay, so I need you to humor me for a second. To write a function is a bit different from what you may be used to. So here we go. First, write fun.
FUN.
Notice how it's bolded. It's special. It's a keyword. We're telling the language that we are writing a function. Next,
Mm-hmm.
space. I'm going to call, so we need to give our function a name. Let's call it f for now. Let's say letter F.
F for Freddy.
Yes. Opening
Okay.
parentheses. And then let's say X, closing parentheses, colon, new line, X plus one. New line?
With spaces, right? X space
Yes.
plus place.
Yes, perfect. And END, N. Perfect.
Right.
Notice how it's all highlighted. So we have just defined a function.
Function. Yep.
Okay. So let me ask you, what is a function?
Function is basically where you input any. It's a process basically where you input a number or anything, and then it processes it to it processes to convert that value of x into y. Like for example, if you put here 1, it will convert it into 2, so, and then if it's like 5 or 7, so it will perform that task and then give you value for every respective value of x to
Hmm.
which will correspond to that. I think so. I don't know.
Very good. No, that's a very good answer. Or put differently, it goes from inputs to outputs, right?
Inputs to outputs. Yep.
Yeah, and it
Yep.
does work to get the output. Yes.
Mm-hmm.
So our function has three things. First, it has a name. It has a name so that we
Mm-hmm.
can refer to it. So
Mm-hmm.
the name of our function is f. Okay?
F, not this one. Not f of x. The name is f. Okay. F,
Yes,
just f. Simple f. Okay.
exactly. Now it has a second thing. It's inputs. That x is our input. That's what goes in.
Right. Yeah. X, what goes in. Yeah.
Okay? But in programming, we call it parameter. So we say that the
Parameter.
function f has parameter x.
Right.
Okay, that's the second thing. The third thing, remember how a function goes from inputs to outputs? We need the output, right?
Yes.
But how do we produce
The
the
output.
output? That's the third thing. It's the body. Line 3, x plus 1, we say that's the body of the function.
Body of function. Yep.
The body is
Body of
what
body of.
produces the output. So third thing, body.
So
Okay.
essentially, three things: f, the name of the function; the input x, which is the parameter; and the body, which is the output. Body is the output.
Very good. Yes, exactly.
Okay,
So the N, the END, that denotes the end of the body. Okay.
Mm-hmm.
All right,
And
let's run
denotes
it.
end of. Okay,
Yeah.
got it.
Let's run it. Okay, we run it, nothing happens. Why does nothing happen? Because we didn't use the function.
Because we didn't put any value of x. There was no input.
Okay, very good. Let's create a new line in our program and let's use this function. So to use a function, first you must refer to it by its name. So the name of our function is f. So let's write f. Next, we write opening parentheses, no space. And then inside the parentheses, just write any number. Okay, very good. Let's run it and see what happens. Ah, what happened here?
The expression is on the same line as another expression. Each expression in a block should be on its own line. If each expression, there should be no space between the function and the arguments. Oh, so it has to be no space. I run it now.
Yes. Very
Oh,
good.
okay, yeah.
Okay, so some terminology. You saw the word arguments, right? So we say
Arguments, okay.
6 is an argument. Okay.
6 is an argument, okay.
So argument is the value, it's the concrete thing, whereas x on line 2 is the parameter.
Okay.
Yeah. So 6 is the concrete thing is argument. The parameter, the variable is called the parameter.
Mm-hmm.
Anyway, that's just terminology. People mix them up all the time. So as long as you understand people and and people understand you, it's all fine.
Right.
Okay.
So basically, like if I say variable or if I say parameter, right? Parameter, it's the
Parameter,
same
yeah.
thing. But in
S-
programming, parameter is a decent word or like the more ideal way to say it, or
Um, in the context of inputs to a function, we prefer to say parameter. It's more specific.
parameter. Parameters. Okay. Parameters.
But
Okay.
mechanically speaking, variable and parameter is more or less the same thing.
Right. Makes sense.
Yeah.
Okay. Thank you. Yeah.
Yeah. Okay. So in mathematics, we say we apply a function. So we apply f on 6. But in programming, we say we call a function. So we
Call a
call f
function.
with
Yeah.
6. Yeah. So
Right.
here
Yeah. Calling.
we did f of 6 and we got a 7. Can you walk me through how we got 7?
Yep. So this function has the body which is x plus 1. So we input the value of 6 and 6 plus 1 is the 7. So the end result is 7.
Very good. So there's a notion of variable substitution, right? The idea that x becomes 6.
Yep. Yeah.
Hmm.
Yes.
Interesting.
Yes.
Very cool. Okay. I want to do something funny. Notice how there are two windows.
Yes.
The window on the left, we've been typing stuff in and this is our program. Window on the right has been giving us answers, right?
Yes.
Let's do something funny. Let's stay in the window on the right. I'd like you to call a function on the window on the right. So let's call
Mm-hmm.
f with a different number. Do
Mm,
not click run. Once
so,
you're done, I would like you to hit enter.
okay.
Yeah, enter.
Enter. Okay. Yeah.
Boom.
Oh, 63.
You got an answer. You saw what happened there?
Yeah.
So the
It
right hand
called the
side,
function. Mm-hmm. Sorry.
yeah, I was just saying the right hand side is like one line programs. You can write one line, hit enter, you can get an answer immediately.
Mm-hmm.
Notice how it knows the F from the left hand side. Okay.
Yeah. Yeah.
All right. I'll explain that more in a moment, but I also want to know one more thing. Notice how we are able to call a function with a different number and got a different answer. And we didn't touch the
Yes.
program.
No.
The left was exactly the same, but we got a new answer. So that's the power of functions. They're reusable. We can the function doesn't have to change, but we can get new things out of it. Okay,
Oh, perfect.
great. Um, so I want to explain more about the left and right windows. So the left window, we call it the definitions. This is where we define our program. Okay.
Definitions. Okay.
So yeah, we can define stuff. We can define a function. We can define variables. All our definitions goes on the left-hand side. The right-hand
Mm-hmm.
side, we call this the REPL. 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 It stands for something.
REP. Mm-hmm.
R for read, it reads what you write. So when you write f of 62, it reads that. E for
Mm-hmm.
evaluate. So evaluate means to simplify. It takes what you write and simplifies it as much as possible.
Mm-hmm.
Evaluate, it also could mean to turn into a value. So there's the word value in evaluate. A value in
Mm-hmm.
programming is that which cannot be reduced anymore. So 63, that number is a value, cannot be reduced any further. Okay?
Mm-hmm.
So evaluate. P is print. Once it gets an answer, it prints it out. So f of 62 is 63, it prints it out.
Yep.
L
Mm-hmm.
for loop. Loop because you can keep doing this again and again and again. Okay?
Right. So
So let's try some.
REPL is basically like, sorry to interrupt. REPL is
Mhm.
basically an acronym for like evaluate. P for what was for R? Sorry, I
Oh, R is read. It reads what you write.
read read what you're. Okay, okay, okay. Thank you. Yeah, makes sense.
Yeah. This is all recorded also if you want to revisit the recording.
Oh, okay, yeah, okay,
Yeah.
yeah. Sorry, I will.
All good, all good. No, but you're welcome to take notes as well. Okay, so let's do something. Can we call f of another number and then multiply? Let's actually no, let's add it. So call f on a number and then add it to a call f on a different number.
Okay.
So f of something plus f of something else. Nice.
Mm.
So the functions they can mix and match. Remember when we did num min last time? Same. In
Yep.
fact,
Number.
num min is a function.
Mm-hmm.
It's a function that someone else has created. Great, great. Okay. So that's it for functions.
Mm-hmm.
So in mathematics, we like to name our functions very short, like one letter. This is because we don't like to write a lot. In programming, however, we like to give our function names very descriptive names because it's very easy and so that people know what we're writing, right?
Right.
It's like
Mm.
nummin. By reading the name, you knew what it does, right?
Yeah. Minimum
Okay,
number.
so I want us to change this function name f to something else. What's a good
Uh,
descriptive name for this function?
Add or
Add?
like
Mhm.
I
What is it doing to
and
the input?
add it's adding one to its value. Like it's
Add
adding
one.
one, add one, yeah.
Add one. Could we call f add one instead?
Yeah.
Okay, let's
Here
change the
we
function
can
name.
do it
Yeah, 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 exactly. You got it. So, and let's change it to add one. Perfect. So
like
in this
that.
language, we prefer to use, so that's correct, but in this language, there's a convention for names. We prefer to use all lowercase and we use dash instead of underscore. Okay, if we run it
Add
right
dash one.
now, exactly, that's perfect. If we run it right now, what would happen?
Um oh yeah. So we have to use it we have to change here as well so that
Exactly.
it because that is not defined here.
Yep,
This
because we
that's
refer
not.
to the function by its name. If the name
Yeah.
changes, we have to change the name. Yeah.
We have to change yeah. If we run it here, then it would become 7. Yeah.
Very nice. Okay, let's delete everything. And we're going to shift gears a little bit. All
Beg
right,
your
I would like you
pardon?
to
Sorry?
write the number. Oh, we're going to shift gears. We're going to do something different.
Okay.
I'd like you to write the
Mm-hmm.
number 5. I'd like you to run it. Okay, get back 5. Nothing surprising. You expect this.
Mm, yeah.
Now let me ask you, what does 5 mean?
5 is an integer or it's a fixed number, like it's constant
It's an integer, it's constant. Okay.
or whole number, and it has a fixed value to it. like
Okay, those are all the
it's
characteristics of the number five. But what does it mean?
five. Um, it is one, no, like one. How do you say it? Like it's a unit number. Like it's one. Like, what does
It's a
it
trick
mean?
question. It's a trick question. Don't worry about it.
Yeah.
I'm trying to trick you. It doesn't mean anything. It's just five. Five is five. Why think so hard, right? Now, let me ask you something different. How about
Yes,
five
please.
degrees Celsius?
Oh, it has a. I understand. Like five. It has no what you say. For 5 degrees Celsius is the measuring of the temperature. So
Okay.
the outside temperature like 5 degrees Celsius. So, uh, yeah, I know what you mean. I just can't find words to explain to you like 5 kilometers or 5 kg or it's like
Yes.
yeah,
So they're all five, right? 5 kilograms, 5 kilometers, five whatever. They're all
yeah,
five. But when I say five
five.
degrees Celsius or 5 kilograms, it means something different, right?
Yes, yes, yes.
Okay. So there are two worlds. There is the world of information. This is ideas
Mm-hmm.
about the real world, facts about the
Right.
real world. And there's the world of data. This is what the computer sees. When we say
Perfect.
5 degrees Celsius, that computer, all it sees is five. All it sees is that five in front of us in our program. It sees data.
Mm-hmm.
We see information. We see 5 degrees Celsius, the computer sees five. It sees data. Okay? It sounds
Okay.
philosophical, but it's a very
Mm.
practical idea. I claim that our role as programmers is to facilitate the interaction between these two worlds. We turn
Yep.
information into data, do stuff with data,
Mm-hmm.
and turn data back into information. Okay?
Mm-hmm.
So we say that we encode information as data. Encode. Another way of saying it is we represent information as data. Represent is
Mm-hmm.
another word. So here's an example. Let's say I have an electronic thermostat. So there's information,
Mm-hmm.
right? Like the thermostat has physical sensors on it that turns information into data. It reads the
Mm-hmm.
electrical resistance in the air, the movement of molecules. It reads all of the numbers, and it has numbers
Right.
in it. Then it performs mathematical operations on those numbers to deduce one
Mm-hmm.
final number. The electronic
Oh.
thermostat does not know that number is the temperature, but it displays it. It displays that number, 5 degrees Celsius. We as the human
Yep.
being, we
Yep.
read the number, 5 degrees Celsius. We get back information.
Mm-hmm. Yep.
Okay? From information to data, data gets processed, data back into information. Okay?
Right.
All
Like,
right.
is it like similar to analog to digital conversion? Like similar to that, or no? I'm like analog to digital
E
conversion of data,
yes.
or
Oh yeah, right. You do field service work, right? Yes, exactly. Um, yes. Um,
and no.
okay, here's the yes part. The yes part is it's taking information is being converted into data. There's no doubt
Yeah,
about that.
information has been, yeah, no, 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 but
The no part is that analog is a form of encoding. It's just
mm-hmm.
encoded differently. It's not encoded as bits. It's not zeros and ones or
Bits.
electricity,
Oh,
but it's
oh,
encoded
yeah,
as
makes
a
sense.
mechanical system. So
Mechanical
it's
system, yeah,
so analog is a different story. It's analog in some ways is also data, but that data is encoded differently. It's not
encoded
zeros and
differently.
ones. It's encoded as
Yep,
mechanical things, right?
right, right.
That is a very good question, though. You're the first person to ask me that. Yeah. Okay, let me drink some water. That was very intense. Okay. Now, I want to reframe everything we've done so far in our past two sessions. We have been encoding information as numbers and
Mm-hmm.
operating on numbers.
Yep.
Okay, here's my question for you. Can we encode all information as numbers?
All information as numbers. as in 10 in bits.
Ah, okay. Yes, you're very clever. Yes. The answer is yes, right?
Yeah, yeah,
We
everything,
can
yes,
encode all
can be
information as
encoded. Yeah,
numbers.
yeah. Oh, yeah, yeah.
Okay. Next question. Do we want to encode all information as numbers?
Because computer only understands this language, we can't understand it, but like computer only understands in this language, I think so. Yes, I think. Do we
Okay.
want to, as in, like, are we forced to, or like, if it's the safest option in, like,
Okay. You have a very pragmatic perspective. You're saying that at some point, all information must be numbers, right? That's what you're saying?
because like, correct me if I'm wrong, like the computer reads only in this language, like in 10 binary language, like 1001.
That's true. Let me offer a different perspective. You and
Yes,
I,
please.
we are transmitting information to each other by talking to each other, right?
Yeah.
But are we talking in numbers?
No,
No.
we are
But
talking
yet
in
we
English
understand each
language.
other. Yes, we're
Yeah,
using language. Hmm. Right? Like, why are we using a programming language? Why are we writing zeros and ones? Right?
that's a good question, which I don't, because it would be very complex. I don't know the answer. I don't
No,
want
no,
to
that
waste
is
your
the
time
answer.
on that.
Complexity. Why don't humans
Oh.
communicate in Morse code? Like, I'm not saying 0 1 1 1 0 or beep boop boop beep, right? I'm using words. Like, why
Yeah.
did humans, like humans have existed for a
Hmm.
long time.
Yeah, long
Human
time,
civilization, we
exactly.
have developed language. It's developed for
Yes.
many, many,
So
many,
many,
many, many,
yeah.
many years.
Oh, yeah.
But
Yeah.
why do we develop language? Why didn't when the language we develop, why is it as complicated? Like, like people learning English, like if you're learning English as your second language, it's like painful because English is so complicated. Why?
Yeah. Yeah. So, we are learning English so that we can communicate with diverse culture, and like begin widely spoken across the world, and like, it's it's
But
speaking in all the West, like,
it's not just English, right? Any language. So like when
yeah,
you
any
learn
language, yeah,
any language that's not your first language is going to be very difficult. It's very complicated.
very
But if
difficult. Yeah,
but to native speakers, it's very easy. It's like natural, right?
exactly, exactly.
So, but why do we talk in languages? Why not zeros and ones?
Because and if we speak in zero, then one, there are only, it would be very difficult, and the combinations for zeros and ones would be very long for every word. So
Hmm.
plus, like, it would be difficult. In simple terms, communication would be very, very difficult.
Efficiency, right?
Efficiency, yeah.
Yes, it boils down to efficiency. So here's another example. You know how they say the universe is just a bunch of particles?
Yeah.
So in front of me, there's a table. I see a
Mm-hmm.
table, but in the eyes of the
Mm-hmm.
universe, it does not see a table, it sees particles,
Yeah.
right? So is it a table or not? Well, I see a table because it's how it's useful to me.
Mm-hmm.
So there's another facet to all this.
Mm-hmm.
It's also about how useful and understandable is it to human beings. Because programming is for humans, right?
Mm-hmm.
Like, for example, there are some programs that is older than both of us. Some programs that have existed since the very early days of computing, like credit card systems, banking systems. Some programs have been running for decades. They outlive the people who write them. But you work in field, you do field work, right? You must like if you work with machines, you have to maintain all these machines, right?
Yeah.
Same thing with programs. You still need human beings to maintain programs.
Um,
So when the
we do,
creators,
yeah. Mm-hmm.
exactly, when the creators they either retire or they die, new humans need to
Mm-hmm.
replace them to work on the same programs.
Mm-hmm. Yep.
And so they need to be able to understand the programs. Yeah.
Hmm.
So, okay, since you do feel well, I'll tell you this. So, like, there are some programs that are very old and that's
Hmm.
very hard to understand, like they're written in
Right.
assembly, but are very critical to human civilization, like banking systems.
Hmm.
Some programs are literally zeros and ones because the source code is forgotten. They literally have zeros and ones. So
Okay.
they have to hire specialists to reverse engineer the program so that they could understand it as a human being.
Really?
True story. I'm not lying to you. It's true story.
No, no,
Sometimes,
no.
yeah,
Yeah.
sometimes there are programs like so. You and I, we write in programming languages, right? That's easy to understand.
Yeah.
But then
Yeah.
they can convert it into machine language so that the computer can understand.
Hmm.
But sometimes maybe it's mismanagement. Maybe a company got bankrupt, whatever. The source code is
Yeah.
lost. And so the program cannot be understood by a human anymore. And so you must hire specialists to reverse engineer the program.
Ooh.
No, no, I'm serious. This happens. So all this is to say, programs are not just for computers. In fact, humans make computers. Programs are for humans.
Humans.
Yes.
No, so, like, can I ask you a quick question in this regard? So, all this programming, like, which people do learn the language like Python, which and this like Pirate, I'm learning, you are teaching me. So,
Yep.
this is for our understanding. Computer, when it is running on a computer, he like that OS only sees like 100100110. That's it. Like,
Yes.
it's so why is it like I'm so sorry to say this. Why is it so complex? Like there are so many restrictions, or like you don't put like that. Why can't they like simple English? It is simple English here, but like like the English we speak, and why is it not written in this? I know my question is very stupid, but
No, no, it's a good
I
question.
was just,
You're asking why do we not write in natural language,
yeah,
right?
the one which we speak. Yeah.
It's funny you say this because right now with ChatGPT, like with LLMs, some people actually do write in natural language to write their programs. But so what you're discussing here is the difference between natural languages, so natural languages like English or like Spanish or whatever,
Mm-hmm.
versus
Mm-hmm.
formal languages. So we say mathematics is a formal language.
Yep.
So like mathematics, maybe we use some words, right? But
Yep.
mathematics at its core is a formal language. It's a logic language, right?
Yeah, logic language,
It's
exactly.
very hard rules, and
Mm-hmm.
every step of the rule is formal, can
Mm-hmm.
be reasoned about.
Yep.
To answer your question, the reason why we write in formal languages rather than natural ones is so that we can reason
Mm-hmm.
about that.
Mm-hmm.
Ultimately, computer systems are mathematical systems. Like
Okay.
the people who created computers are not programmers. The people who created computers are engineers, mathematicians.
Right.
First, you need the mathematics. The system must be self-consistent. It must make sense. If your system doesn't make sense, this whole thing doesn't work. So that's
Yep.
one thing. The second thing,
Mm-hmm.
you need the physical manifestation of these mathematical ideas. So right now we
Okay.
have computers, we have logic gates, we have electricity flowing in very tiny physical devices in our computers,
Yep.
right? But back in the days, we didn't always have this. Last time they used vacuum tubes. I, I don't know how old you are, but like I'm guessing that that might even be older than you. Like very old computers, they don't use
Mm-hmm.
electricity. They use different technology. They use different physical processes to make things happen,
Oh.
right? Yeah. So yeah, that's a very long answer to your question, but yeah, that's why we use formal
Mm-hmm.
languages instead of natural ones. But there's a lot of research that goes into how we can use natural languages to talk to the computer, and LLMs is one of them.
Right.
Okay. Uh oh yeah, yeah, that was a very fun aside. Okay, let's come back. Let's come back. Yeah, all this is very like philosophical, theoretical, but let's come back to programming. Um, so what we can conclude from this is that there's information in the world. And although they can be encoded into numbers, we wish for other
Mhm.
forms of representations, other ways to encode information, right?
Right.
So we talked about language, words, using words.
Hmm.
Could we use words in our programming languages? And the answer is yes. I'd like you to
Yep.
delete that five. I'd like you to write double quotes,
Double quotes.
double quotes, quotes. Those are a lot of symbols. It's the one to the left of enter. Yes, perfect. Okay, and write hello, comma space world. Closing double quotes. Notice green. Let's hit run. Let's see what happens. Hello world. Tell the computer hello world, it tells you back hello world. That is not a number. So far we've been getting numbers, but that is the first time we got something that is not a number.
Yep.
That is a string.
String.
A
Yeah.
string
Array of
of
number. Array of.
characters.
Array. Yeah. Array of character. Yeah.
Okay. So we are able to encode something that isn't numbers. And that we are able to encode in means other than numbers. Okay. So just last time we had numbers and we could perform arithmetic on numbers. Now could we
Hmm.
perform arithmetic on strings? Can you add this string to another string?
Don't think so. But do you want me to try and write?
That's right. We'll never know unless we try it.
Delete this, correct?
Oh, don't delete it. I'd like you to keep that string and add it to another string.
Okay. Sorry.
Yeah. Hello, Marvin. Nice. Hello. All right, let's run it. Let's see what happens. Hmm.
Hmm. Interesting.
So it joins the string together. So the same way we can add two
Yeah.
numbers, we can add two strings. There's a form of quote unquote arithmetic on strings, right?
Hmm.
Okay, I want to give two notices. The first is that we have moved beyond a calculator. Last time we've been working with numbers and we've been using this like a calculator.
Yep.
Now it's the
Yep.
first time we're doing things beyond just numbers. We're now beyond a
Yeah.
calculator. The second
Hmm.
thing, I forgot to explain what is Hello World. In the 1970s, there was a guy who wrote a book on how to program. Oh yeah, back then, like right now, if you want to learn how to program, right, there's billions of books on there on the subject.
Oh, yeah. Yeah.
But back then, that's rare. Someone writing a book on programming is a
Hmm.
very rare thing. So someone
Hmm.
wrote a book on how to program, a very established person, he wrote
Hmm.
how to program, and he used this
Hmm.
example, Hello World.
Hmm.
Ever since that day, every book,
Okay.
every video, every tutorial, every lecture uses this example, Hello World. It is
Yeah.
a
Yeah.
rite of passage.
Hmm.
Everyone must do this. I did it. I wrote Hello World once. So
I've heard that it's
congratulations.
a lucky charm. Like it's a lucky charm as well. Like I
Yeah.
was reading on the internet as well. Like Hello World is like and like when you write it, every lecture. Sorry to cut you. Like every lecture, every course in the world basically uses this phrase "Hello World" to like that's the first program every book.
Yeah. It's a rite of passage. Everyone does it. And congratulations, you have reached a very important milestone in your life today.
Thank you.
Yeah, you can go out and celebrate later. Do something special. Okay. All right. Okay. Back to this. So we've just performed arithmetic on strings. Could you replace the
Oh,
plus with a minus?
yep.
Okay. Let's run it. See what happens. Oh, what happened here?
Evaluating this minus expression error. Hello world minus hello Marvin. The left side was hello, comma, world. The right side was hello. The operator expects to be given two numbers. Show program evaluation trace. Oh, So it negative like can only be used with numbers, I believe. It like the strings cannot be subtracted from each other, I think.
Yeah, because it doesn't make sense, right? What does it mean to subtract
Yeah.
two strings? So we can only subtract numbers. Hmm.
Hmm.
Okay. S- So arithmetic, what arithmetic means for numbers means fundamentally different for what arithmetic means for strings. Can we
Right.
delete everything? And I'd like you to write double quotes, 5. All right, now run. Okay, nothing special. The same way we can say hello world, get back hello world. We can say 5
Yep.
in string, we get back 5 in string. Nothing
Mm.
special.
Mm.
Can you
Yep.
write the number on a new line, number 5, not in strings? Just a regular number 5. Now run it. Okay, I have a question for you. Now that we have strings, and
Mm-hmm.
strings are a series of characters, and a number is
Yep.
displayed as a series of characters, why do we need numbers? Why not make everything strings?
If possible, can you please repeat your question? I know, like it just
Yeah, so there's two fives in front of us, right? One in string
yes,
and
a
one that
string
is not
and
in
one is
string.
a
One's a
number.
number.
Yeah.
Why not make
Yeah.
everything the first thing?
Because I think if we use the first thing, then we cannot use minus. Like some arithmetic operators cannot be used, so that would be restricted. So we need numbers as well, so that we can use those arithmetic operators like negative.
Okay, sorry, can you continue your answer?
Yeah, I think because five in the string one is restricted by the arithmetic operators we can use. So, for example, if I need to use negative like minus, I cannot use it on string. I think, but I can use it on number five. Maybe that's the reason it has certain restrictions when it comes to string.
Very good. That's a
Or
very good
like if
answer. Yeah, they're operationally different.
yeah.
So while the same piece of information can be represented with multiple data types, there are
Hmm.
strengths and weaknesses to each data type. Yeah.
Okay.
Yeah. Now, as you say, yeah, we can't subtract two strings, but we can subtract two numbers.
No, but if
So,
can I like I'm so sorry to cut you. Can
mhm.
I quickly
No, of
ask you a
course.
question? For
Mhm.
example, if I were to do five minus um this, it wouldn't work, or would it work? No.
Let's run it.
Oh
No. It's like
no,
as far as the computer is concerned, it just got a string. It doesn't know that it does a number inside a string. It's just a string.
it doesn't matter. String is a string. Like we
Yeah.
cannot do negative. Okay, okay.
Okay. So yeah, a part of our job as a programmer is to decide the most appropriate representation for a given piece of information, right?
Like data type, like the type of like um
Ah,
like
yes, you say the word data type. Yes, that's the classification of our data. Yeah, we choose the right data type. And data type data types aren't the only choice we make for data representation. Soon you will learn about data structures. Yeah, we'll get to there. That's futurist. Okay, so just to summarize, we have covered numbers and strings, and we can perform
mm-hmm.
arithmetic on each one of them. But arithmetic looks
Yep.
fundamentally different for each one. Cool. Let's okay. While we're on this train, let's do something different. We have encoded numbers like numeric like mathematics. We have encoded mathematics essentially, and we're able to encode
Mm-hmm.
words. I want to
Yep.
encode a new thing that is very important in life, and that's decisions. Okay. It can be
That's
said that
what.
life is a series of decisions where a decision is
Mm-hmm.
fundamentally yes or no. For example, your
Yep.
decision to come to office hours, you must have said yes, right? Computers are
devices.
making decisions all the time.
Mm-hmm.
So decisions, very powerful. So yes or no, right or wrong, left or right, true or false. These ideas of
Yeah.
dualities. In
Mm-hmm.
in programming, in
Exactly.
computer science, we call these booleans. And we use the words
Booleans.
true and false. Yeah, booleans.
Booleans, yeah.
The name came from the person George Boole. He's a mathematician who studied these things as mathematical objects. All right. So let's delete the fives in front of us. I'd like you to write true, TRUE, and run.
Oh.
We write true, we get back true. Notice how the true is red as well, special. So this is one of the
Mm-hmm.
booleans. I'd like you to delete the true and
Mm-hmm.
write false. Uh, the swap the S and L.
Oh, sorry.
Oh, it's all good. Very
False
good.
is false.
So so numbers, right? Numbers you can write 1, 2, 3, 4, 5, 6, 7. Like there's so many numbers. Or
Mm-hmm.
strings, you can write so many things. You can say hello world, hello
Yeah.
Marvin. You can say many things.
Anything. Yeah.
Booleans, there's only two values.
True.
True
Yeah.
or false.
Or false. Yeah.
That's it. No more. That's it. That's what makes it special. There's only two things. Great. Now, we talked about arithmetic for numbers and strings, but is there arithmetic for booleans? There is. Could you write false and true? That's false and true.
Like that or
Lowercase.
a small
Yeah, small.
and
Let's run
run?
it. Yeah. Go back false.
False.
False and true is false. Okay. Could you change and to or? Let's run it. False or true is true. So notice that the thing in the middle is bolded. We call that a Boolean operator. We're able to combine
Mm-hmm.
two Booleans into one. So we are able to perform arithmetic on Booleans. Okay?
Mm-hmm.
The same way
So,
we can add two.
or and I beg your pardon, sorry to interrupt. And or is arithmetic operator in this regard. Like if we call this arithmetic operators. Like I know plus, minus, multiplication, division, or this is as well. Like for Boolean, this is the arithmetic operator, correct?
Yes.
Or and or
Yep.
nor or like no and so.
Ah, okay, yeah. So you have advanced knowledge in this area. Yes. But we call these Boolean operators. In this
Boolean
language,
operators
there are only three, and, or, and not.
and or and not. Okay, yeah.
In this language. In other languages, there may be more or less. There would be more. Yeah, every language is a
Yeah.
bit different. All right, I'm gonna do a bit of explaining. I'm gonna share my screen in 1 second. Give me 1 second. So I think you will understand this concept very easily because of your background. Okay, let me pull this up. Okay, I'm gonna share my screen. I think you can keep sharing yours. Okay, let me know once you see my screen. Do you see my screen?
I think I have to stop sharing it and then I would be able to. I don't know.
Okay,
I
sure,
don't.
yeah.
Let
Yeah,
me try stop sharing it
yeah,
and
that's fine.
then I would ask you to. Yeah, I can see it now. Yeah, I'm viewing your screen. Yeah.
Great. Okay, so
Yeah,
right in
I've
front of
seen these.
us.
Yeah, I've seen
Okay,
these. Yeah.
you're gonna.
Mm.
Okay, this is very easy for you, but I'll do a
I'm
bit of
familiar with.
explaining.
Oh yes, please.
Uh,
Yeah, yeah. Just
remember how we say that computers are zeros and ones?
yes. Yeah.
These are the zeros and ones, and the things. Okay,
Mm-hmm.
so first, these tables can be understood as functions. Conceptually, they are functions. They have input and output.
Internet truth tables.
Yeah, and these are so yeah. Another way of understanding booleans is that they encode truth. Zero is false, one is true. You know this, and they combine in certain ways. For example, zero and one is zero. Zero
Zero.
and
Yeah.
zero or one is one.
Mm-hmm.
So these are the zeros and ones that make our computers. And the reason why they can change is because of these physical devices on top. Our computers, the same way the universe is a soup of particles, our computers are a soup of zeros and ones. And the reason why these zeros and ones can change is because of these physical devices. They are constantly stirring the soup. And this is what makes computation possible.
Mhm.
All right. As programmers, we need to know not and or. For these others, unless you're into low-level programming like assembly language, unless you're into cybersecurity or you're an electrical engineer, you don't really need to know them.
As a programmer, only need to know this one not
Not
and
and or. These three. Yeah.
okay.
Okay. But yeah, since because of your background, I think you're very advanced in this, so I don't have to spend much time on this. Okay, I'm gonna stop sharing my screen. We have 9 more minutes. We have a lot of time actually. Yeah, if you could share your screen again.
Okay, let me share.
So I'll show you how to write not. So not in this language is a bit different. First, I want you to write not not, open parentheses, and let's write true, closing parentheses, and then run. There we go. So that's how you use not in this language. You have to use parentheses.
Okay,
Okay?
not parentheses true.
Yep.
Okay.
All right. Next, I want to show you something cool. Give me 1 second. I'm gonna paste a piece of code in chat, and I just want you to copy and paste it into your program. Give me 1 second. Yeah, if you could, I just pasted in chat. If you could copy that and paste into your program, and don't run it yet.
In the chat, where is the chat?
The app.zoom.us is sharing your screen. You need to hide that. You see at the bottom, bottom, go all the way down. You see the white text box. You gotta press hide.
Oh yeah. Oh
Yeah,
yeah.
okay, now you can
Sorry.
see the chat. It was hiding. All these things hiding.
Hmm.
All right, yeah, let's paste that in. And before you run it, what do you think will happen when we press run?
Oh, okay. Yeah. So it will create a circle of 30 radius or 30 diameter with, so it would color it red inside in solid red color, like solid.
Cool. Okay, let's run it.
Yeah.
Very good. This is our
And
fourth data type with covered numbers, strings, and booleans. This
mhm,
language has images. So a data type, it doesn't need an existential reason to exist. Now, it
mhm.
doesn't need to be fundamentally philosophical. It could just be useful. This language is designed for beginners, and oftentimes beginners are children, and images are fun to work with. So this language has images. Great.
Perfect.
So just like you said a good thing, like, oh, that's a 30, that's probably size, but I don't know if it's pixels, is it radius, is it diameter? How do we find
Mhm.
out?
Um, by like looking at like the manual of this language, maybe like there would be data type. Maybe it's a circumference, not a circumference. It would be diameter or.
Very
So,
good. Okay, so you said like the reference of the language. Okay, because you come from this background, you're used to thinking like this. Yeah, so that circle is a function. Someone must have made that function. We don't know who that person is, but we don't have to because we can refer to the manual. So like when we are learning a language, right? Oftentimes we'll have a dictionary with us. When we see a word we don't understand, we look up the dictionary. And
okay.
we don't learn a dictionary, sorry, we don't learn a language by reading a dictionary from top to bottom, from A to Z.
Mm. No,
Same thing with programming. We refer to a manual and we refer to it when we need to. So I'm going to send you the manual for this.
fine.
Give me 1 second. Okay, in Zoom chat, I'm pasting in a link if you could click on that. So here, this is the definition of a circle.
Mm-hmm.
So we can see
Oh
it's a
yeah, find
radius
it.
to answer your question.
Yeah.
Okay, and
Mm-hmm.
I want to note a few things while we're here. First, notice how I'm going to draw real quick. I think you can see my drawing. This here. Oh, wait. Sorry, this whole thing here. I'm drawing a circle.
Mm-hmm.
We call this the
Yeah, I can see it.
signature. So there are three things. First, oh,
Oh, what happened?
can you go back to the can you go back to the documentation?
Yep.
Okay, so yeah, so first, that's the name. These are the inputs, and then that's the output. Okay,
Yep.
so we call this the
Underneath
signature.
that.
Yeah. So this is then how do you refer to the function, the name, the inputs, and the output? So that's all you need. This is data. This is what the computer understands. Okay.
Mm-hmm.
Below that, we see a description. This is for the human. This is what the human understands. This is what this means. Okay. Okay. So there's a lot here. So we call this the documentation. We don't really say the word manual. We say documentation. Sometimes you may hear
Documentation.
reference. Yeah. Okay. I gotta start wrapping up. It's almost time. Do you want homework? It's up to
Yes,
you.
please.
Okay, I'll
Yes,
give you
please.
some homework. I've never heard anyone so happy to want homework. Okay, I'll give you homework, man. I'll give you homework.
Thank you.
Okay, I'm very happy to hear your enthusiasm to learning this. Okay, to end my sessions, I always like to ask people, what's one thing you learned today that stuck with you?
Today, again, I would say that honestly, I would say that it's a very positive experience for me in learning. Like I do feel that I can openly ask questions, and individualized knowledge from you or like attention from you is really very helpful and superb. And thank you so much for your time. Appreciate it. Thank you.
Of course, anytime. Yeah. Okay, yeah,
I
very
just
happy
have
to
one
hear that.
question. I know you have another session, just 1 minute maximum, I think.
Okay.
How can I, apart from learning from you, if I need to boost my progress, what can I do in, my free time? Like watch tutorials or like CS50 or other like courses or book you can recommend,
Yeah,
or
so
we
I
can
base all
talk
my
in next session.
sessions. Yeah, I base all my
Mhm.
sessions on the books. I'll send you the books as well as exercises. I'll email you.
Mhm.
I'll email you. All right.
Okay. Okay. Please.
All right.
Thank you.
I hope to see you again. Bye bye.
See you. Bye.